Welcome. Oh, can you hear me? Yes. Thank you so much for coming out. I think this is the biggest post-COVID crowd we've had, which is exciting. We are excited to, I hope it's exciting. We are excited to have Evan Hadingham back with us. He is the senior science editor of the PBS NOVA series produced in Boston. He has an MA in prehistory and archaeology from the University of Sheffield. And he has popular books on archaeology, including Circles and Standing Stones, Secrets of the Ice Age, Early Man and the Cosmos, and Lines to the Mountain Gods. So thank you, Evan, for being here. 2 housekeeping notes. For those of us who are joining on Zoom, put your questions in the chat, and I will raise my hand and read them aloud. And we are recording for broadcast on Waycam, our local cable access station, as well as the library's YouTube. So I'll get out of the way and adjust the lights. Thank you, Evan.
Sure. Everybody hear me? Okay.
Yes.
Yeah. When I came down here 20 minutes ago with my family, I was intensely excited to see in one corner, for just $1, very British problems. How awkwardly British are you? Now, as an ex-Brit, this is going to be my best present for this year. So we're going to be playing this on Christmas Day, Boxing Day. There you go. So I hope you'll let me know if there are any awkward problems over what I'm going to say. I hope anything you miss or want clarification, of course, we'll talk about it at the end. Courtney's intro was correct, except in one regard. I am not the senior science editor of NOVA at GBH. I retired exactly a year ago, so I'm an ordinary civilian now. And a lot of people come up to me, in our neighborhood when I'm out walking along Dudley Pond, and they ask, the standard question, how are you enjoying retirement? And I come up with usually some rather lame answers like, I have more time for social life, hobbies, doing things with Janet and so on. But the real answer is that increasingly I've been waking up each morning astonished to find that I'm still here when so many others, friends and family, have passed on. Each day my gratitude grows that I live in such a privileged place when so many around the world are suffering. How did I get here? I'm amazed at how little forward planning I did in making my life decisions, including the decision to leave my native Britain. I just trusted that everything would somehow work out. Looking back, my life seems like one long chain of improbable events, one after another, that led to my being here. And that brings me to the subject of my talk. I want to take us all on a journey through deep time and space to explore scientific evidence that points to the extreme improbability that we're all here and that humans ever came to exist in the first place. Humanity and our ancestors in the remote past faced many challenges that I think, many more challenges than I think most of us assume. There were many make or break points along the way, but somehow we made it through. Our journey through time and space will touch on some of the biggest questions that science and religion have always been trying to answer. How and why did we get here? Why is the world the way it is? And how have the answers to those questions changed over the centuries? Now, of course, there's a huge variety of indigenous stories about how the universe came to be. In Native American traditions, animals often take the leading role in creating the earth, and humans only come along later in the story, almost as an afterthought. The Iroquois, for example, say that the world begins as a vast expanse of water, inhabited only by water creatures such as the beaver, muskrat, duck, and turtle. To create the earth, they cooperate to try and bring soil from the bottom of the waters. After several attempts by larger animals, it's the humble muskrat who succeeds in bringing up a bit of soil and placing it on the turtle's back. Now there's some solid ground for a sky woman to land on after she falls from the sky world above. Eventually, she gives birth to the evil spirit and the good spirit, who create the rest of the animals, plants, and natural features. Humans come along only after everything else has emerged. So, in the Iroquois worldview, we're part of a larger connected ecosystem, not the central focus of creation. But the outlook of Western civilization, beginning with the ancient Greeks, was very different. Aristotle believed that the universe is made up of 10 crystal spheres, you see here, with the Earth at the center, and the other spheres nested around it in a concentric pattern. He classified living things into a hierarchy, with humans at the top because of their capacity for reason. Aristotle's classification of living things was adapted into a Christian framework by the 4th century theologian and philosopher St. Augustine. In the Middle Ages, his scheme became known as the Great Chain of Being, pictured as a ladder with rocks and plants at the bottom. See there? Rising up through animals, humans, then angels, and finally God, the source of all creation, who is, of course, represented as an all-powerful male. Pictured here in an engraving from 1579, the Great Chain of Being and its hierarchical view of the universe became a highly influential cosmological and moral framework for humanity. Right at the bottom of that same engraving are the unfortunate souls who have tumbled into the eternal fires of hell. I imagine that the smell of roasting flesh must have wafted up to the more privileged layers above. With the advent of the Renaissance, scientific discoveries began demoting the Earth and humanity from that central place in nature, a process that has continued ever since. The starting point was the publication of Copernicus's book De Revolutionibus in 1543, about the revolutions, right? Not social revolutions, the orbits of the planets. This book, of course, laid out the essentials of today's solar system and placed the sun at the center of the universe. This literally earth-shattering conclusion was, Copernicus said, and I'm quoting, suggested by the systematic process of events in the harmony of the whole universe, if only we face the facts, as they say, with both eyes wide open. In this engraving from the book, we see the sun at the center, Sol, you see, and with the Earth and 5 planets known at the time, including the moon, which orbits the Earth. When Galileo directed his telescope towards Jupiter and saw its orbiting moons, his discovery, which was published in 1610, helped build confidence that Copernicus's sun-centered theory was correct. The Church begged to disagree with the new cosmology, and disagreeing with the Church could get you into serious hot water, or rather, fire. In 1600, Giordano Bruno was charged with heresy by the Italian Inquisition and burned at the stake, partly for supporting Copernicus, but also other unorthodox theories. For example, he argued that the planets might harbor alien life and proposed an infinite universe with multiple worlds and stars. Ironically, today the multiverse, or concept of multiple worlds, is one of the most fashionable theories in cosmology, though how we can test it is a big drawback. Fast forward to the last century, when astronomers, using the forerunners of today's instruments and techniques, began to discover the scale of our cosmic neighborhood, the Milky Way. Henrietta Leavitt faced many challenges in a male-dominated field and was hearing impaired, but she persevered and joined the permanent staff of the Harvard Observatory in 1902. She made the breakthrough discovery of variable stars, which brightened and dimmed according to a regular cycle. This allowed her to use them as a yardstick for measuring how far away they were from the Earth. Now here we see her supervising with her assistants at the observatory, searching photographic plates for those variable stars. The technique Leavitt developed continues to be used today by astronomers calculating the size of the universe and how fast it's expanding. Astronomer Edwin Hubble used Leavitt's technique to measure distances from Earth to other galaxies for the first time. In 1923, at what was then the world's largest telescope at Mount Wilson near Pasadena. Isn't it amazing? He's sitting right in the telescope. Well, at this huge telescope, Hubble detected a variable star in the Andromeda galaxy and calculated that it was about 1 million light years from Earth. That meant the universe was hundreds of times bigger than anyone had ever previously expected. Hubble's pioneering work began to dramatically shrink our sense of cosmic self-importance. Thanks to pioneers like Leavitt, Hubble, and their successors, we now know that the Sun is one of over 100 billion stars in the Milky Way. And the Milky Way is just an average-sized galaxy among the roughly 100 billion galaxies in the observable universe. In 2004, the Space Telescope, named after Edwin Hubble, captured this famous image known as the Hubble Ultra Deep Field. To capture it, Hubble combined 800 different shots taken over the course of 400 orbits around the Earth, with a total exposure time of over 11 days. The result is like peering through a keyhole at the universe. This image covers only a tiny patch of night sky, about 1/10 the diameter of the full moon. Now, you can imagine this, it corresponds roughly to if you hold up an if you hold up an aspirin in front of you like this, that represents, about the similar keyhole that the telescope is looking through. Hubble's image shows that this tiny slice of sky contains an estimated 10,000 galaxies, some of them among the oldest and most distant objects in the universe. In 2022, an international collaboration of observers using infrared telescopes published this image. That unpromising-looking red blob is actually the most distant galaxy yet observed. In fact, it's the oldest and most distant object of any kind ever detected by science. Its incredibly faint light has taken 13.5 billion years to reach us. That's a mere 3 million years after the Big Bang. It's inconceivably far away from the Earth, 8 times 10 to the 22 miles. That's 8 with 22 zeros after it. Now, if you find that daunting to grasp, let's look at something much closer in our cosmic backyard. Besides the Sun, the closest star in our Milky Way is called Proxima Centauri. It would take one of today's space probes 25,000 years to get there. Maybe it would be good if we put Elon in one of those probes. Anyway, the conclusion, the universe is a mighty big place. So what does all this groundbreaking research add up to? We now know that our Sun is one of over 100 billion stars in the Milky Way. The Milky Way is just an average-sized galaxy among the roughly 100 billion galaxies in the observable universe. And to sum up this drastic shift in perspective since the Middle Ages, I can do no better than read you my favorite quote from The Hitchhiker's Guide to the Galaxy by Douglas Adams. quote, "Far out in the uncharted backwaters of the unfashionable end of the western spiral arm of the galaxy lies a small, unregarded yellow sun. Orbiting this at roughly 92 million miles is an utterly insignificant little blue-green planet whose ape-descended life forms are so amazingly primitive that they still think digital watches are a pretty neat idea." Along with this growing grasp of the vastness of space has come an equally huge shift in our perspective on time. Today, thanks to advances in geology and cosmology, we now view the whole of humanity's existence as a mere blip in the 4.5 billion year history of Earth. Let's revisit the famous timeline figured out by astronomer and TV celebrity Carl Sagan, which squeezes the entire history of the universe into a single year, beginning with the Big Bang on January 1st. In this drastically shrunken timeline, the Milky Way forms in March, Earth forms on September 1st, and the dinosaurs go extinct on December 26th. All human history since the invention of stone tools takes place in the final hour of New Year's Eve, while all recorded civilization lasts just 22 seconds during the final minute of December 31st. That's enough to make anybody feel humble. But there's another way of looking at all this. While we're not nature's main feature attraction, we're fantastically lucky to be here at all. Let's take one obvious example. Without the 6 Mile asteroid that wiped out the dinosaurs 66 million years ago, it's unlikely that the tiny shrew-like mammals that existed back then would ever have had a chance to evolve into the huge diversity of primates that eventually gave rise to us. The chances of such a giant asteroid impact were incredibly unlikely. A similar-sized collision is predicted to happen only once about every 250 to 500 million years, thankfully. To take another example, there was nothing inevitable about the emergence and survival of our species, Homo sapiens. From DNA studies published over many years, it's been clear that the prehistoric ancestors of everybody alive today outside Africa came perilously close to extinction. By measuring the amount of diversity or variation present in today's genomes, the genomes of living people, scientists have found that a drastic bottleneck or narrowing must have occurred in the size of human populations around the time that our ancestors left Africa, starting about 60,000 years ago. Now, here you see a kind of a metaphor for a population bottleneck. I find this very intuitive to imagine. You know, just think of this as the population before the bottleneck. It's all got a nice diversity and variety in it. And then something happens, and we'll talk about what may have happened in a second. And you only get a trickle of stuff down, and that means there's going to be less variation, less diversity in what's left over. And so you end up with, a very non-diverse population. One estimate suggests that that from a total population of around 35,000 in Africa, the migrant ancestral population may have dwindled to as few as 4,500 for several thousand years, putting them at serious risk of extinction. This population collapse has several possible explanations. It could have been due to disease as our ancestors moved into unfamiliar environments. So there's several explanations for what was happening with our population. It could have been due to disease as our ancestors moved into unfamiliar environments outside Africa. or it could have been the impact of a severe cold and arid climate at that time, or simply geographic isolation of small scattered populations as they spread into new lands. Whatever happened, this scenario suggests how close our human lineage came to dying out during the critical period of expansion outside our African cradle. But finally, let's consider perhaps the strangest and most controversial evidence of all, which makes not only humanity's existence, but also the entire universe seem wildly improbable. It comes from the realm of physics, and it's called the fine-tuning problem. The first scientist to draw attention to it was British astronomer Fred Hoyle back in 1951. Hoyle was a highly original thinker with wide interests. He wrote a book about the astronomy of Stonehenge and an ingenious sci-fi novel called The Black Cloud, in which an alien intelligence takes the form of a gas cloud that threatens to shut off sunlight from the Earth. I finally read it this summer on the beach, and it's really quite a page-turner. I recommend it. Now, Hoyle started out as a staunch atheist who resisted the idea of the Big Bang because he thought it implied the existence of a creator. But when he came to study how the conditions for carbon, the element necessary for all life, could have formed from the nuclear reactions inside stars, he was startled to discover that the process could only happen if there was an incredibly improbable, exquisitely finely balanced combination of forces, precise to within 1 part in 1,000. That led Hoyle to make a famous remark, which I'm going to try and do in his inimitable Yorkshire accent. He said that the universe seemed like a put-up job. A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Hoyle's study was just the beginning. Today, most physicists agree that roughly 30 basic constants of nature, such as the masses of elementary particles, the strengths of fundamental forces, had to be just so to make the universe and life possible. Now, I'm not going to give you 30 examples, I'm going to give you just one. If gravity, the force of gravity, had been stronger or weaker by just 1 part in 10 to the minus 40, that's 10 with 40 zeros after it, then life-sustaining stars like the sun could not exist. Now, is this dumb luck, or is it because, as my physicist Freeman Dyson put it in one of my favorite quotations of all time, it's as if the universe knew we were coming? It's just a lovely, lovely thought, that, Stephen Hawking wrote that, quote, "The odds against a universe like ours emerging out of something like the Big Bang are enormous. I think there are clearly religious implications." Unfortunately, that's the end of the quote. Hawking didn't go on to say anything more beyond that vague statement. So the fine-tuning of nature's basic physical properties makes the entire existence of the universe seem wildly improbable. But it's equally extraordinary that our fragile species on an utterly insignificant blue-green planet should have been able to discover so much about the history of the universe and the hidden mathematical laws that underlie all of nature. And my other favorite quote from the British physicist Paul Davies, and in his great book, Cosmic Jackpot, he wrote, "Somehow the universe has engineered not just its own awareness, but also its own comprehension. The evolving cosmos has spawned beings who were able not merely to watch the show, but to unravel the plot. The more we discover about the intricacy and delicacy of the balance in the cosmos, the more reason we have found to be amazed that we are all alive. End of quote. So while the perspective of science is a humbling one, it can also instill in all of us a sense of wonder and gratitude, enriched by an understanding of the extraordinary luck that we're here at all. Thanks very much. Love to take your questions. I thought I'd just finish with kind of an interesting thing, because just around the time, 2 days before the election, New York Times ran an op-ed piece, which I was startled to see echoes my talk very much. Amidst all that election weight of coverage, they saw fit to run this op-ed by a cosmologist, Paul Stotter. And I'm just going to read a couple of bits of it. And he says, I'm a cosmologist, the kind of scientist who studies the origin, history, and evolution of the universe. I've spent my career researching one special part of the universe called cosmic voids. Those are the vast expanses of nothing that stretch between the galaxies. Talk about giving yourself a hard field to study. I study nothing, right? Yes. Most of our universe is void. Somewhere around 80% of the volume of the cosmos is made of nothing at all. Now, there is a temptation when faced with the true scale of the empty cosmos to look at our tiny world with nihilism, to feel that our great achievements amount to nothing, that our history fails to leave a mark, that our concerns and anxieties are rendered meaningless, that our very humanity is reduced to irrelevancy. It's true that in cosmic terms, Earth is neither large nor long-lived, but that is only one way of measuring significance. Compared with the voids, there is something special happening on our planet. Despite decades of searching, Earth is still the only known place in the entire universe where conscious beings raise their curious eyes to the sky and wonder. Earth is the only known place where humanity exists, where humanity can exist. It is the only known place where laughter, love, anger, and joy exist. The only known place where we can find dance, music, art, politics, and cosmology. Our disagreements and jealousies and all the beautiful complexities that make us human aren't meaningless. The presence and dominance of the cosmic voids guarantee the opposite. The stories and experiences we fill our lives with are special precisely because they will never happen in the empty expanse of most of the universe. And his wrap-up. Billions of years from now, the sun will engorge and Earth will turn to dust. The cosmic voids, guardians of great nothingness, will remain. That bare fact, at first uncomfortable, gives us the ability to treasure what we're given. Tell a joke to your friends. Fight for what you believe in. Call your mother. Create something the cosmos hasn't seen before. The implacability of the cosmic voids calls us to action. The universe won't do anything for us except give us the freedom to exist. What we do with that existence is entirely up to us. It's our responsibility to imbue the cosmos with meaning and purpose. You see how amazed I was to come across this. Just, yeah.
What was the author of that?
There's a guy, Paul Sutter, is a theoretical cosmologist.
British.
No, I forget. I actually looked up where he's from. I can't remember. Anyway, he's got a great webpage, does lots of public outreach. You know, he's one of those speakers who puts his science out there. So. Sorry, I've given you way too much to think about. Yeah.
There's one question from Zoom. Do you think there is life out there besides on Earth, and is it likely to be like ours, carbon-based?
Well, that's one of the classic questions. How common is life are we or creatures like us out there? And for perspective on that, I was thinking one good way to answer it is that the Kepler mission has been searching for other worlds, other inhabitable worlds outside our solar system, right? Through this incredibly ingenious, sensitive technique that is involved, like it's sort of like an eclipse, that an incredibly distant planet coming in across the face of a star diminishes the light just by a fractional amount. And remember how far away this is happening. So it's incredible that we can pick up that phenomenon. And so far, I looked it up today, what's the count? There are, it's counted so far 2,778 of these exoplanets outside the solar system. Now, out of that total, 2,300 are rocky planets, meaning they've got solid surfaces, with some hope of, of supporting, as opposed to gas planets where presumably there is no life. So far, 30 of them have habitable zones, that is, planets orbiting their star at a distance roughly similar to the Earth, suggesting the possibility of life. Although I was a bit disappointed to see that tonight that's recently been revised down to about 2 to 12 so far. Remember, they've just started on this search. If it's just 2 to 12, then I think it chimes in more with the improbability. I mean, how likely is it? I think it's rather unlikely on that score. On the other hand, we don't know is the universe infinite. We don't know. It stops. We can only observe so much. If it's infinite, then hey, anything's possible. So.
So we are the Lord of the universe. Then.
What?
So we are the Lord of the universe.
There you go. Don't let it go to your head.
So the bottleneck that you're talking about.
Yeah.
Were you talking about just and I just need to correct you.
Yeah.
On something else, by the way. I'll talk about it later. You want me to do the correction first? You said it was 3 million past the Big Bang. It's actually 300 million.
Oh, whatever I said.
Yeah. Because 13.8 is the Big Bang.
Oh, yeah.
0.5 would be 300 million.
That's very true. Thank you. Yeah.
But the bottleneck that you mentioned, was that just the people that remained in Africa, or both the people that remained in Africa?
No, they left behind a much more diverse population in Africa. So this happened as they're coming out and getting into Asia and Europe. Eventually, it takes a long time for them to spread. So it was during that process and we just really don't know whether it's a matter of just isolated pockets of people and the others die out for one reason or another, and that leads eventually to our modern global population. Or whether it was whether it really was, one group that suffered disease or what have you. We just don't know, but it happened for a while, and clearly, now the rest of the world, I wanted to add this, you mustn't imagine the rest of the world was devoid of people at this time, because in Europe and Asia, there were the Neanderthals and these other human species that had left Africa long before, but they eventually, first of all, shortly after this exodus from Africa, we went through a period of doing the wild thing with Neanderthals, so we did actually mix with them to some degree, because their traces are in our population today. But eventually, we were the last humans standing, so to speak, which was by about 40, 50,000, And again, thinking about that we're not so privileged, it really wasn't that long ago in time that we were just one of this diverse numbers of different flavors of being human. And there's no really necessarily reason why good old Homo sapiens came through. Some people argue we had special abilities and qualities, but that's it's getting more and more contentious. Yeah.
If I may ask an extension of the same question, so does that bottleneck mean that actually number of gene pools is much lower than what is expected when the whole thing started in NASA.
Yes, that's exactly right. Yeah,
So
yeah.
we are a whole lot more homogeneous in that respect
Yes,
than what was expected to be.
yes, that's right. Yes, and that allows them to measure back in time and create an estimate of when this dwindling
So
happened.
we're all related to one another, each other.
We are all related to one another. We are all from Africa. You know, we all had dark skin in the beginning, so you know. So much for white supremacy. Don't get me started. Yeah, 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 yeah.
I have a question connected less with what you've spoken about today than to the operation of the NOVA program.
Oh,
A lot of people are familiar with the notion of the Koch brothers,
yeah.
K-O-C-H. Right? Some of us in Massachusetts know that there were two sets of Koch brothers.
Yep.
And are most aware perhaps of Bill Koch.
Yep.
Who's relatively left of center politically to the extent that there is one political spectrum.
Yep.
David Koch was on the right end of that spectrum to the extent that it exists, but was a major funder for NOVA. And at the same time, supporting politicians who question climate change.
Sure.
And the COVID pandemic and so on. Do you have any idea of how he found it possible, or the people that he dealt with at NOVA found it possible, to be supported by him
Sure.
without interfering with the scientific concept?
I can address that because we, as you can imagine, received innumerable letters during the period of Koch sponsorship. David Koch died, forget how many years ago now, and we lost $1 million in funding that was completely essential to putting NOVA on the air. I have to correct your estimate, your political coloration of the two brothers, because I have read in detail the biography of the Koch brothers. It was actually the other one who was really appalling politically. I mean, they were both libertarians, and I have no time for libertarian viewpoints. Let me make that clear. David would... I went to dinner with him twice with my boss, and I will tell you the extent of his interference. We would provide a little folder to him. Here are the upcoming NOVA programs. This is at dinner at wherever he was. He was like this jolly old Santa Claus guy. He was the first jovial person. He would sit at a table. He'd look at this folder and say, "Oh, yes. Oh, this looks lovely. Lovely. Fine. There you are." That is the extent of his editorial influence over NOVA. We absolutely never, ever had any problems whatsoever in our editorial independence. As I've had to explain over and over again, we don't allow that kind of thing from any funder. Now, was I unhappy at this credit coming up? Yeah, but I will tell you that the series has been struggling ever since to replace that source of funding. And in fact, we're in, not me, because I left, but I'm still doing some consulting work for them, so I should be in the present tense. We are still fighting all the time to do more with less. And that's true of public broadcasting as well. I mean, public broadcasting is pretty endangered, I would say, on a lot of fronts. Federal funding is not that huge a worry because it's only about 14%. So... But it just means it's, for a lot of people in the creative and journalistic worlds, things are getting harder. Yeah. Yeah.
Another question. It's more of a technical question. Regarding the red blob that you showed,
Yeah.
That was done by infrared telescopes. The infrared telescope obviously
Yes.
Detects heat.
Yes.
So how probable it is for a telescope to detect very, 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 very long distance.
I don't know. The only thing I know is that the sort of state-of-the-art Keck telescope, getting, is the most sensitive observing instrument of all time, and it's that's bringing in this level of observation. So the answer must be that in the infrared you can detect much further out than you can with ordinary light. That's my. That's my. I just made that up, but it sounds plausible to me. So, yeah.
Are there no sensors of that type on the vehicles that are going throughout the galaxy? Is that not possible to have infrared sensors? I forget the names. We just saw the NOVA show.
Yeah.
We recorded it.
Yeah, but the size of that telescope is humongous. It's enormous, and a lot of that is to do with, I think, with the cooling mechanisms of bringing down the observing instruments down to some incredibly low temperature in outer space. And
the vehicles that are out there don't have the capacity when they get really close, because some of them get really close to planets and stars, to pick up.
well, they're not. I mean, our probes are well within our solar system. That's in our backyard. That's a stone's throw in our backyard. And I mean, Keck is looking, on another continent, essentially. But, yeah.
How does time figure into that? Are they finding things that don't exist anymore or existed millions of years ago?
Don't exist anymore. Oh, yes, sure. I mean, the further back you look in time, the further away you look, the further you are back in time. So that's why we can develop our theories of cosmology, because we are constantly trying to push that boundary further back to earlier and earlier, and the more we can find out, the earlier we can find out about the initial conditions of how everything emerged, the more it helps build up our theories for what happened right after the Big Bang, how galaxies, I mean, there's a lot of issues that astronomers don't understand about exactly how galaxies formed, and right now they seem to be at a very early stage of the universe. They seem to be already bigger than they're supposed to be. So that's one of the type of problems that you can get, that they're trying to get at by doing this kind of early observations. Yeah.
I'm not a physicist, but I do know of time warp, that time does bend and all that kind of stuff. So if that is the case, and if that is the reality as a matter of fact,
Yeah.
then how sure we are we're talking about billions and trillions of years? So how real are they really? You understand what I'm saying?
You're saying that because of gravity.
The time gets bent by different poles, including gravity.
Yeah.
Proved actually, and so if that is the case, and so when you're talking about time,
It's space that gets bent. I was worried that somebody would get onto relativity or something. I'm a dilettante journalist, and I have half an inch of knowledge about most things, but I mean, gravity bends light, which is why you get these funny images. Because if you have a star and you've got light, but you've got a heavy object like gravity, it will, like a planet, or it's going to curve the light coming over, and you see that in these strange double images that telescopes pick up. So it's not that time gets bent. Ginny, help me. Okay.
They're calling it space-time now.
There you go. Whatever. Yeah. No, I'm going to back out of trying to do relativity after this talk. Sorry. Just feel lucky, for goodness sake. Yeah.
So you focused on the physics improbability.
Yeah.
Could you talk just a little bit about the biological improbability and the Cambrian revolution and all that, Cambrian explosion and improbability of all of that?
Well, I mean, one thing is that, Earth being such a friendly place for life, was it really? Because for an awfully long time, it was an awfully hostile place. And so the Earth forms 4.5 billion years ago. It takes, by the latest estimate, it takes 2.7 billion years before cyanobacteria, oxygen forms, right? So the only creatures, no plants, the only creatures that were around for all that time, 2.79 billion years, were anaerobic bacteria, and so there's no life doing photosynthesis, right? And what happens is that cyanobacteria come along at that point, and they start to produce oxygen in an explosion of productivity, essentially, and form our atmosphere. Before that, Earth is a lifeless, barren place. And so think of that. I mean, that's just inconceivable length of time. And I'm even worse at biology than I am at relativity. But there are many. I think there is a lot of contingency in all these processes at every stage. Evolution is not a foreordained thing. It's a combination of what we have, and it's constantly shifting and responding to environmental pressures and its own adaptability, right?
Evan,
Yeah.
when you talk about the observable universe,
Yeah.
is there a theory about how big the beyond the observable universe is? How much
By definition, no, because we don't know. That's the limit of our knowledge. So beyond that, we don't know if it's infinite. It kind of represents the end of our observing and the end of our ideas for what's, or the end of our certainties. There's plenty of theories, right? Of course. So. Yeah.
Tell me if this is getting outside what we ought to be talking about. I read somewhere as a throwaway that proto-humans and early humans didn't encounter one bottleneck where
Yeah.
population crashed. They may have encountered as many as 6. Really?
Well, there's a lot of theorizing going on at the moment. And there was a prior version of my talk that I changed today. That slide of the bottleneck with the bottles and the little golf balls in it, that was new as of today, because the slide and that research that I had in there before, a blog I happened to subscribe to, showed, again, improbability, right? Improbably, today, I looked in my computer and saw an entry in that blog with a study that completely threw out and disproved, utterly disproved, this very wonderful example that I had ready to show you. So I actually went to this more accepted version that I gave to you today, and this has been around. The main out of Africa bottleneck, as it's called, our African exodus from our homeland. That's been around for a long time, multiple studies. So some version of that is definitely true. But population genetics, you can do a lot of different interpretations. It's playing with statistics, So.
And we all know about playing this.
Yeah. Yeah.
But we were watching a NOVA show that was on recently about the cosmos.
Yeah.
What was the name of the episode? It was about the planets and existence.
Yeah.
And it was the one that talked about the far, far, or far off, far off. Had a really funny name. Far off. Yeah, far something. Object. It was that episode. And I laughed at the name because they didn't have a name. It was very recent. And they and the scientists were talking about they could trace the origin of these bodies that are moving
Yeah.
by their trajectories. I don't know the name for the
Yeah.
process, but by their trajectories, they could go back, literally go back to their source, like whichever. What do you call the clusters?
Hmm.
Yeah, and then so I'm thinking about your bottleneck and humanity, and whether it's a similar process of trajectory that people, humans that floated out away from their origin could be traced back either genetically or
Through their measuring of the diversity that's around in all of us today.
Yeah.
You can extrapolate back from that.
I'm just wondering
Yeah.
if there's something similar to that process.
I have no idea, to be honest with you. No.
Interesting to think
Yeah.
about.
Yeah.
Because we're like the stars, the things, whatever.
Yeah.
The shootings of meteorites that are
Yeah.
floating around.
That's a nice poetic thought too. Yeah.
We do have genes that can be traced. Yeah.
Yeah.
A long time ago, I thought of doing a postdoc at Salk Institute, and they were doing actually the science, the primordial science, to make the primordial mix to create life. And so now we know
Yes.
that we can actually create life in a bottle.
Yes. Yeah. Yeah. Well, not life, but the amino acids that are key ingredients in the cookbook of life. Yeah. Yeah. And we know that they are out there. So the possibilities of them, that they've still got to land in exactly the right sort of environment to get that creativity going, So I do have. Let me just, if I can add further, what is the meaning of this fine tuning? Because there's been 3 or 4 explanations for it that are favorite explanations. Many working physicists just accept it and say, listen, I'm talking about all those finely tuned constants that seem to be incredibly finely balanced in order to make life or planets or anything, any kind of atoms possible. And, one attitude is that, well, that's just the way it is, and we're here to observe it, so of course, it's the way we can observe it, otherwise we wouldn't observe it. And there's, an anecdote that says, well, if you're in front of a firing squad and there's 50 people aiming a rifle at you and they all miss, would you shrug your shoulders and just say, well, that's just the way it is? No, you'd be curious to know what on earth is going on, okay, right? One objection is, could life take on other quite different forms than just our regular carbon-based life? Well, how do you test that? That doesn't seem like an answer. So really the most favorite thing that a lot of cosmologists go for is talking about the multiple universe, the multiverse. And, there's a very fashionable and well-supported theory that there are, in fact, not just one Big Bang, but multiple Big Bangs with different laws, multiple Big Bangs, so the universe is going pop, pop, pop all over the place. And perhaps each one of those has got its own special laws where things are not so finely tuned for life. And the point is that this makes our universe not so special, because in fact we're just one amongst a whole crowd of universes. I think it's a total cop-out, and a lot of Paul Davies thinks it is too. And he makes the point, well, what creates this bubblegum machine in the first place? What's the mechanism behind this? There are laws, obviously, creating that. So where did they come from? It's just like pushing the explanation off to another level. So then, okay, so is life and complexity kind of baked into creation from the very beginning? Is consciousness and life somehow bound up and an inevitability as things evolve? which of course shades off into the G word, you know.
Yeah, right, the spirituality.
Yeah, so that's where it's at. That those really are the main choices to explain all this. Explain why we're all here, you know.
Being in a library, I do have a book recommendation for you about evolutionary biology. It's called The Vital Question by Nick Lane.
Oh, great.
He's an evolutionary biologist.
He's a good writer, yeah.
He's a very good writer.
Yeah.
And he talks about what the evolutionary evidence is for some things, where it's missing, where there's a theory, but they don't have full enough things. But it's a very worthwhile read, The Vital Question.
Great, yeah. I recommend this book too, particularly for... Okay.
Thank you, Evan.
Thank you. Yeah. Wonderful questions. Thank you so much.